Welcome! My name is Fabio Rinaldi. I currently work at the Dalle Molle Institute for Artificial Intelligence, ITSIA, in Lugano, where I am responsible for NLP research. Previously, and until recently, I was a senior researcher and principal investigator at the Institute of Computational Linguistics of the University of Zurich. The results that I am going to present today are the outcome of a collaborative project sponsored by the Human Resources Unit of a major pharmaceutical company. Since the beginning of the project, a few of the people involved, including myself, have changed their affiliation, and that is why you see so many affiliations listed in this slide. I'm going to give you first the background and goals of the project, then briefly describe the methods that we used, and finally some results and conclusions. We start with the background and goals of the project. The scenario that we are considering is the recruitment of advanced professional figures, typically high-level managers, which is performed by a specialized subunit within the Human Resources Department. Typically, in such a situation, the recruiters go actively looking for suitable candidates. In other words, they consult numerous sources, for example LinkedIn, but also company portals and others, and look for candidates that potentially match the profile requested. However, this is a very expensive and time-consuming process, which involves the manual analysis of hundreds of candidates' profiles. The purpose of this project is to develop tools that can make the process more efficient by identifying specific items of interest in the profiles and by doing a pre-classification of the profiles into predefined broad categories. In order to improve the quality and efficiency of this pre-selection process, we explored in this project name identity recognition tools applied to the candidate profiles. Despite the existence of many commercial providers of similar services, there are no publicly available datasets to evaluate advanced algorithms that this system claims to be using. Because of that, during the course of this project, we constructed our own corpus derived from fragments of real CVs, and we manually annotated these CVs for various types of entities of interest to us. Now we look at the methods. We are interested in different types of entities, like job titles, therapeutic areas, geographical areas, but also biomedical terms more in general. Since we are working with a pharma company, they might be specifically interested in people who have worked with specific targets, specific diseases or drugs. We can capture efficiently biomedical terms with a pipeline that my group has developed in the past few years that has been described in other presentations at this conference. We are also interested in capturing geographical locations. For example, a senior manager in a specific geographic area might have linguistics of cultural competencies that are particularly relevant for that area. Geographical areas are organized in a hierarchy. In this figure, you can see a fragment of that hierarchy. This slide illustrates the variety of job titles that can be found in the profiles. Notice also the frequent usage of abbreviations, which typically have a very contextualized interpretation. Here we see a concrete example of a sentence from a profile, where different entity types need to be identified. Roles in purple, locations in green, and organizations in red. Let's now come to the methods that we adopted. First of all, we wanted to test existing pre-trained models for the recognition of these entities. In particular, we tested the Stanford NER tools and SPACY, an open source software library for advanced natural language processing. The problem with such pre-trained models is that they are trained on generic text, typically based on well-structured sentences, such as those that can be found in news articles. A frequent corpus used for training these models is Wikipedia, which has also typically well-structured sentences. However, CVEs are rarely written entirely in the form of well-structured sentences. A lot of information is conveyed in the form of bullet points, lists, not in the form of well-structured sentences, but rather in the form of headings. Here we see an example. If we apply the pre-trained models of SPACY to the sentence that we have seen before, none of the entities that we are looking for will be identified correctly. Therefore, we asked domain experts to manually annotate a reference dataset of free text job title descriptions extracted from CVs. Then we use this corpus to train a deep learning model and compare the results against the reference models mentioned above. Now we move to the results. In this table, we see a comparison of results of the Stanford NER tools and SPACY. Unfortunately, SPACY is not capable of recognizing titles by default. If we consider strict evaluation, where the type and span of the entity annotations have to match exactly the ones in the gold standard, then the Stanford tools perform better. However, if we consider a lenient evaluation, where a partial span match is considered positive, then SPACY performs better. We decided to train our own models using the recent deep learning approaches of BERT and DistilBERT. And on this slide, you can see the results. BERT on the left and DistilBERT on the right. We can see that both models outperform the pre-trained models in precision on titles and organizations like companies and schools. However, both do less well than the pre-trained models in recall. Additionally, these models are capable of recognizing entity types that the pre-trained models cannot recognize. We have therefore the advantage that we can define the entity types that are most suitable to our project. Another goal of this project is to pre-classify different profiles from a pool of profiles into possible target areas. Ideally, the set of target areas could be defined arbitrarily. But for the purpose of this experiment, we consider division into three classes: medical positions, general administration positions, or not related to any of them. So we have three classes. In order to do this classification, we want to verify which zone or section of the profile provides the most discriminatory information. In this slide, you see the results. On the left, the legend describes the zones that we have considered, and on the right, the results. It is easy to see that the current role section is the most informative, which could be sort of expected. Adding additional sections, for example, as you see in the CRS that combines current role and summary, or all. Adding this additional material does not help, and in fact, it lowers the results. Added zones taken alone also perform worse. So we have come to the conclusion. We have shown results from a collaborative project where we train NER models specialized to recognize entities of interest in CVs. We have shown that our models outperform pre-trained models. Additionally, we have presented initial experiments of automatic classification of profiles into specific job categories. Our models have been integrated into a prototype system based on Docker modules, which combine open source components such as Elasticsearch and our own modules described before, and offer access to a web API. The system is already being used internally at the industrial partner, and it replaces a couple of previously adopted commercial solutions, thus contributing to significant savings. And with this, I'd like to conclude my presentation and thank you all for your attention.